Okay, let's do a linear programming problem that involves a product mix situation. We've got a company that makes grape soda pop and orange soda pop. The profit is $1 per unit, which could be like a gallon, for example, or a pint, or even a can, whereas orange is $1.50 in profit. The mixing time is 1 minute for grape, and the time it takes to mix orange is 1.5 minutes. And the bottling time is a half a minute for grape and 3/4 of a minute for orange. Those are our inputs to the model. Any input is in blue here in this model. And then the decision variables are the number of units to produce here in orange. And I've just put those arbitrarily in there as 0 to begin with. That's what the linear program is going to figure out. We want to figure out how many units to produce in order to maximize our overall profit, assuming we can sell everything we make. But we have these constraints. We can't just make an unlimited amount of grape and orange and call it a day. We have to be subject to the constraints of real life. So the mixing constraint is that the total amount of time invested in mixing must be less than 3,000 minutes, because that's all that's available for that week in the mixing department. So what we do is I use the sum product function right here. Sum product, I took C18 and D18, which is the decision variables, multiply and sum up those two values multiplied by the mixing time, which is here in B, what is this, C13 and D13. So we got C18 and D18 and C13 and D13 in the sum product function right here. And then for the bottling constraint, it's the same idea. You do sum product on these two, but instead of having row 13, it's row 14, C14 and D14, right here, the bottling time. That should be less than or equal to 3,000 minutes in the mixing department and 3,600 minutes in the bottling department. And we also have a grape constraint, is that we have a unit of an order for 100 units of grape. So C18, which is grape, must be greater than or equal to 100 units. Then the objective function is how much profit we will make. We want the optimal solution to make the most profit possible. So what we do is we do sum product again. We take the number of units in the optimal solution, and we multiply that and sum up it with the profit, which is this row, which is row C, cells C12 and D12. And that's what I have here. I took C12 and D12 and sum product it over C18 and D18, because we want to maximize that. Okay, so that's the problem. So how do we actually solve this problem in Solver? We go to Data, we go to Solver, and we put our mouse on the profit function. So we click on that by changing, and we highlight the orange cells because they're the decision variables. And then we're going to have to add 3 constraints. So we click on Add. We want to say that this mixing constraint formula, which was a sum product formula there, must be less than or equal to, which is the default, 3,000. Click on OK. Add. This must be less than or equal to that. So the formula in cell C22 must be less than or equal to that 3,600, which is in cell E22. Click on OK. And then we have to add one more constraint, and that's the grape order constraint. The number of units of grape must be, and then we have to change this here, greater than or equal to 100. We click on OK. And then we have to make sure this checkbox is checked, and then we have to make sure we pick the simplex linear programming option. Click on Solve. Click on OK. It said it found a solution, which is good. So what it's saying here is that the number of units that we should produce would be 3,000 units of grape and 0 orange. Now why is that when orange has greater profit than grape does? And I think the reason is that it takes so much little less time to mix and bottle grape that we can make up that difference in profit by just making a lot of grape. It'd be almost like the profit per minute is higher for grape than it is for orange because it doesn't take um, as long to make it. And then that would be our solution. So let's see if you can solve this problem yourself. Thanks.